This is a video on smooth vector-valued functions. The question states, find the open intervals on which the curve is smooth. And we have the curve defined by the vector-valued function, r of t is equal to t plus 1 over t I plus t squared minus 2t j. So a curve defined by a vector-valued function is smooth if the derivatives of each of the components are continuous and if the derivative of the vector-valued function is not zero, and that means not zero for both components simultaneously. So first, if we look at these components, t squared minus 2t is a polynomial, so it has a continuous derivative for all values of t, and t minus 1 over t is not continuous, and its derivative is not continuous when t is equal to 0. So we can immediately say that the curve is not smooth at t equals 0. So now let's find out when r prime is equal to 0. So r prime of t, the derivative of t plus 1 over t, is 1 minus 1 over t squared, and the derivative of t squared minus 2t is 2t minus 2. So r prime of t is 1 minus 1 over t squared I plus 2t minus 2 j. So I set r prime of t equal to 0 by finding out when the components are both equal to 0. So we set 1 minus 1 over t squared equals 0 and 2t minus 2 equals 0. So 2t minus 2 equals 0 when t equals 1. And notice that when t equals 1, 1 minus 1 over 1 squared is also equal to 0. So since both of these components are equal to 0 when t equals 1, we can say that the curve is not smooth at t equals 1. Had only one of the components been 0 at t equals 1, so for example, when t equals negative 1, 1 minus 1 over t squared is 0, but 2 times negative 1 minus 2 is not 0, so only one of the components is 0. And it is smooth when exactly one component is 0 and the other is not equal to 0. So now I can state my conclusion. I can conclude that the curve is smooth on the open interval from negative infinity to 0, and on the open interval from 0 to 1, and on the open interval from 1 to infinity. And I'm done with the problem.